We're going to write the nth term of this sequence, so basically the general form of this sequence. So the key here is you're trying to look for patterns. What I would think of is like this, the first number is the first term, so n equals 1. Where's my pen? So that's 1. Second is n equals 2. Third is n equals 3, and so on. So if you can see a pattern based off the term number, it's pretty simple, and you can really see that happening if it's 1 over n. Let's see, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared. So it's 1 over n squared, it looks like. 1 over n squared. So the first term, 1 over 1, which is 1. Second, 1 over 2 squared, which is 1/4, and then 1 over 3 squared, which is 1/9, and 1 over 4 squared, which is 1 over 16, etc., etc., etc. However, we have this negative. It's an alternating signs here. Every other term is negative. So to do that, you would raise -1 to either the nth or the n plus first, depending on how it goes. So I haven't really checked it yet. So let's just see what happens. If I use this n plus 1, the first term would be -1 to the 1 plus 1, which is 2, which would make this positive. So the first term would be positive 1 over 1. Perfect. The second term, n equals 2, would be -1 to the third. That would make that an odd exponent, which would make this negative. So -1 over 4. So yeah, it looks like it's working to how I wanted it to work. So in other words, if it was this instead, then I would have thought, well, -1 to the n plus 1 won't work because I need the first term to be negative. So I would have just made this -1 to the n. And then now my first term, n equals 1, would make that first term negative. The second term, when n is 2, -1 squared is positive, so that second term will be positive. So just think about that. For this particular sequence, this is most definitely the nth term. So that's it.